A very good afternoon to everyone. On behalf of IEEE Student Bunch, we welcome you all. Today we are excited to have Professor RangaRao Venkatesha Prasad within us. Currently, he is an associate professor at Embedded Software Group, Delft University of Technology, Netherlands. His research interests are in the area of IoT, cyber physical system, energy harvesting, and millimeter wave networks. He served several European and Dutch national projects. He served the editorial board of many international journals, magazines, including IEEE Transaction on Team Communication Networks, IEEE JSAC, IEEE Communication Magazine, IEEE Surveys and Tutorials, and Elsevier Communication Networks. He co-authored more than 400 publications. Recognizing his research contribution to IoT, he has been selected as an IEEE Communication Society Distinguished Lecturer on IoT for the period 2016 to 2018. He is a senior member of IEEE and ACM. He was responsible for the signing of MoU between IISc and TU Delft, and he is also anchoring ISRO and TU Delft cooperation. He completed his PhD from IISc in 2003. His thesis work on scalable VoIP conference platform led to a startup venture, S-Cube Communication Solution, which was selected as top 100 IT innovation in India in 2006 by NASSCOM, and top 100 promising companies in Asia by Red Herring in 2008. Now, to express our gratitude and respect, I would like to request Dr. Pritam Kumar to welcome Professor Prasad with a bouquet of flowers. So, without further ado, I would like to call Professor.
So much. Probably it's not required. Okay. Now, before we start, right? Keep it a little bit lower. Who's come front and then sit. I wanted to check. Normally the tendency is to always sit back, right? Okay. Good. And that's your reward. Okay. These are nice French chocolates. Okay. Yes. Good. For the past 3 days, I'm not feeling well, and Professor Pritam Kumar actually got me very good food. So there is a high possibility that I may fall asleep. Okay, so you have to wake me up by asking me more questions. Okay, so are you ready? Good. See the front page, and I'll come back to this later. Today I'm going to talk a bit generally about Internet of Things, because I heard that there is a mix of students in the bachelor's and then some others who are doing research directly. So it will be some sort of a balance between both types of things. So I have a nice Indian flag here, so that's why I keep wearing this. I still hold my Indian passport. If I relinquish it, then I will be divorced by my wife, so I don't want to take a chance there. This is one of the projects that I am working on. to some extent, my salary comes from this project, so I acknowledge them. If someone has taken the photo, then I will send it to the project managers. Okay. ICT penetration, right? This is the way things are working nowadays, isn't it? So it's not that difficult to understand that we have to now move on and then make more innovations, because it's going to touch each and every life. Not only people in cities, right? So for those people who are supposed to have left the whole universe, right? In some sense, disattached people. Okay, so of course I use some of the pictures from internet for education purposes, because under the new, but in Europe it is much more important that we acknowledge anything that we use. And as a research students, academicians, you should always acknowledge what you use and for what purpose you use. Okay, and there are some of my students who also helped me with this. To quickly move on, I come from Netherlands. Battery is weak, I think. So you must be knowing the capital city is Amsterdam. It's little more than around 18 million population, one of the highest population density in the world, apart from Bangladesh. Netherlands it's a small country, half of the state of Karnataka, or probably it is almost equivalent to Bihar, I think. And also the other thing, 1/4 of the country is below the sea level. The place where I am working now, Delft University of Technology, you are able to see? Okay. So it's about 1.7 meters below the sea level. So that means people there should be really working hard to keep the sea at bay, right? So that also actually gives a very good opportunity. And then they are really tall people, but recently Sweden has taken over. Okay, this was something else. Okay, let us see. You could see that tulips, they are very famous. They make huge amount of money by exporting tulips. Bihar can do a lot, not with respect to tulips, but many other exotic flowers. You can grow tulips, you cannot here. These are those wooden shoes. It's the icon of Netherlands that's used so that you will not get into the sand and soaked sand, right? And also windmills, and of course there are many more multinational companies there. Windmills, those are the almost 300-year-old windmills. They're still working, but in the olden days, windmills were used to flush the water again back to the sea. So they were very efficient, energy efficient. So Delft is in the Hague and Rotterdam. You must have heard about Hague, right? How many? Okay, you are all geeks, right? So that's why you don't know social studies. So the first thing that I studied in social studies was the International Court of Justice, right? Good. And then we won last month. Remember, there was a case against Pakistan. Okay, fine. Let us move forward. Philips, probably you know the brand, right? It's a big one. They're doing lots and lots of innovation. ASML, many of the chips that you see now, they don't make chips, but actually they make the machines that make chips. So that's one of the fantastic companies there. And of course there are so many. And this is my university campus. We have about a lakh, a little bit more in the city. So these are the pictures from the city. It's a very old city, 500 years old. And then the value that they keep they give for the old things is much, much nicer. I think we should also learn. If you go to forts, in India, we have to protect it. It can actually help. Probably you should be doing some work in future to preserve the heritage of this country. There, they also do that. So you could see that this is almost 400 years old. This is the thing, and then these are the canals, and this is one of those churches which is actually in this picture you cannot see, but it's actually leaning like Pisa Tower. It was because the person who was building it, he used to stay across the road, and then from his house he used to tell how to bring it. So naturally, flat thing, yes. So anyway, I think we'll move forward. This is university. It's almost more than 175 years old. So lots of students, around 25,000 students now, bachelor's, master's, and PhD put together. So we have very good ratings worldwide. Probably you should check that. It's also important to be moving in that direction. Competition is important, but competition is not the only thing in life, right? So you have to make that balance, because that's how you will be also keeping yourself happy, right? Anyway, I don't think we'll talk about these numbers and other things. So we select the rankings where we are higher, because there are so many rankings, right? So now we are in the top 50 in the Times World Ranking. QS ranking was better, and some of them are really good architecture. But if someone is from computer science, you can also go and then work in architecture department, because they have now IoT chair. There is artificial intelligence chair there now in industrial design, for example. One of my colleagues is going to start there. So they're mixing multiple disciplines, and probably in the future, this is what is going to happen. You will not be saying that I'm computer science and I want to do only computer science. There is nothing going to be like that. Okay. Let us. I think battery is gone. Is there another battery? Okay, maybe you can bring it. I'll move with this. Yeah. So in my faculty, it's called Electrical Engineering, Mathematics, and Computer Science. We work from hardware to the software, then systems to the individual component wise. We also have a lab center so that students can make chips themselves, test it out. So lots of these aspects are looked into. There's a lot of research happening there. What I want to do is I want to simply move towards one of the important things that I want to tell. Yeah. So there is a lot of work with system on chip, where probably you must have heard these days about microcontrollers, right? So it can do a lot more things compared to the olden days of microprocessor side, right? And then this is a flexible solar panel that's being done. So you can actually put it on a curved surface. You can put it on a car. You can put it on a curved, let's say, arc, for example. You can put it anywhere you want in that sense, right? And then, of course, a lot of systems work there. Then lighting systems, we work a lot with Philips, and of course Nokia. And there is a lot of funding from Microsoft. We have a lab where a quantum computer is being built, and it has been tested. And we also have a nuclear facility, so a reactor where students actually generate alpha, beta, and gamma rays, whatever those X-rays from actually even the neutrons and protons that they can separate and then use it. interestingly, sometimes they even do testing on passing those gamma rays through cheese and then trying to tell which cheese is tasty because of the structure, because of the component or the molecular structure. Because you can pass those gamma rays because the gamma rays are so small, they can find out the molecular structure easily. So it is not just that you have to only do physics, and our nuclear reactor is also responsible for troubling India and Pakistan, because AQ Khan studied PhD in TU Delft. So, and then I think I can safely tell here, he stole it from TU Delft, many of the things. Anyway, let us move forward. So we also, my areas are in Internet of Things, sensing, bit of signal processing, and things like that. What I want to do is I want to tell you a very brief thing before I go to the next slide. I don't want to spend much here. You could see something here. That's called organ on chip. So it is basically a stem cell tissue which is put on a cell, on a chip, so that you can actually measure what exactly happens if you inject medicine, for example, or if a person is running at 10 kilometers per second, for example. It cannot happen at this point of time because heart muscles cannot really do that. But if you just imagine what can happen, right? So then you can do the test there, because it's a stem cell which can mimic a heart muscle, and assuming that you stress the heart muscle, saying that, okay, it is pumping blood at that rate, right? So you can do lots and lots of experiments, and you can actually take away the animal-based experiments till the last moment, right? You can inject medicine, you can stress, you can give electrical signals, you can do a lot of that. And of course, this radar can look almost 50 kilometers in the sky. So they do lots and lots of environmental measurements, and that is fuel cell. About 2 years back, IIT director came, and then we drove him around the campus in a fuel cell car. When Professor RangaRao basically what we do is we take the solar energy and then convert it into hydrogen and oxygen, and then use it for running a car. So it is working. And of course, virtual reality, and then visual analytics, lots of social network. Last one is an interesting thing. So we have a course on robotics, which is taught by a robot. Okay, and every year students actually improve the working of the robot. So lots of these interesting things are happening. Of course, mathematics, which is part of the things. My recent activities is with respect to nanosatellites. Still trying to get something working with ISRO, but these two are nanosatellites which were launched 2 years back. When ISRO launched 104 satellites, probably you remember. So out of 104, 3 are from ISRO, and 101 from others. And actually out of that, 87 came from Delft, but it's from a company. And those, the proprietors of companies were actually 10 years before they studied in TU Delft. And then they made a student satellite, and now they have a company of 100 people, and then they made almost 90 satellites, and it was launched. But we worked, with my student, we worked on 2 nanosatellites. So we gave modules, GPS positioning modules, because the satellites, when it's moving around, if they take a picture, so you should also like to know where exactly the satellite is at that moment. Okay? And these satellites in low Earth orbit would be moving at around 8,000 kilometers per hour. Now, by the time you actually find out what is its location, it would have already gone to another 5 kilometers away, right? But the important thing is locating the satellite where it is. When it takes a picture is very important. Just imagine it takes a picture of a glacier. from two different points, and if you know exactly the position of the satellite at these 2 points, then you can actually estimate the height of the glacier, right? So positioning system is very important, and the positioning system that we gave was only costing about 15,000 rupees. So a lot of innovation you can do, and probably ISRO will be much more kind enough to take payloads from Indian students, for example, IITs here, than Delft, which is a foreign university. Okay, let us move forward. Because the topic is Internet of Things, I talked a lot about other things now. Do you know who is this person? Who said that? Very good. Okay. So I don't know whether you remember these things. At least I remember. I'm old enough. And of course, internet cafes, and then we started looking into mobile phones, internet connected mobile phones, and then now we're talking about machine-to-machine communication and the spread of internet connectivity across each and everything, right? So, and that's what is called as Internet of Things. Let me stress a little bit slowly, right? This is some of the major things. I could get up to 2007, but there are a lot more things that have happened, including Twitter and many other things, WhatsApp, for example. Can you say something about all these companies? What is common between all these companies? Huh? Very good. Okay. So, all these companies, right, they all survive on internet. And internet is not owned by any country, right? Not owned by any person. But all these companies are making huge amount of money. If you take Microsoft, Google, Amazon, and one more, Facebook. If you take these four companies, and if you pull in all the money, they can actually buy India. And that is the amount that these companies have. Okay, just 4 companies, and they survive on publicly funded internet infrastructure. Okay, so I don't think I'll go into these things. And to give a broader picture, you could see that it touches vehicles, right? It touches public applications, and then, for example, communication for public, hospitality, hotels, and many others, right? They also use this internet. Of course, energy, smart meters, right? You take anything, they all survive on somehow getting connected to internet. And this communication actually brings a lot of value for them, right? And what enables all of these things is the simple concept of Internet of Things, right? And this is a very nice moment around 2006-07, right? When the number of connected devices exceeded the number of people on Earth, right? I have 1, 2, right? And I have already 3. So my internet connection. Now, how many you are holding, right? So each and every of us, we are actually having so many devices. And then forget about the people, right? If you look at the buildings, the number of devices that you have in this hall, for example. Right? So what is going to happen is you are going to have 50 billion expectedly, right, by 2020. Probably we are not there yet, but we are going to reach such an enormous number, right? So it is so many devices, and these devices need to be connected, are always connected to the internet. So you could see now the challenges. Having a mobile phone, maybe 2 mobile phones is not going to cause big surprise or a big problem, right? But when you have 50 billion devices talking at the same time, then you have to really think about how to make it work, right? So you can now start thinking about what are the research questions that you have to really solve to make it happen that you are able to have 50 billion devices continuously connected to internet, right? Okay. This is a very old one. Of course, you can get it 2019. Have you heard about this? Gartner hype cycle? No? Can you see where is Internet of Things? That's here. Okay? So, Gartner hype cycle basically tells you should go and then look at this because it's very important for you to keep looking at this. If you want to do research, if you want to do your thesis project, I'll tell you why it is important, at least for students. For companies, of course, they look into it because they should know where to fund or when to fund. Right? So this Gartner hype cycle basically tells you what are the important topics at this point of time where people are really interested in, they are looking into. So something that comes here, like let's say smart dust, so it will move. Now quantum computing is here, but actually quantum computing is now has come to this level. So what happens is, if somebody comes up and then talks about a new idea or new thing, so everyone will start jumping into that, right? And it goes up. There is so much of efforts, people are talking about doing some research, companies putting funds, government putting funds into the area, right? It goes up here. But after some time, you will not be able to sustain the same force. So it dips. And then it goes to some sort of a bottom stuff, and then slowly picks up because the amount of efforts that have been put earlier, right, is not going to be wasted. So then it will slowly pick up again, and then it reaches a plateau. So as research students or students who would like to do some state-of-the-art job, right? I don't think you are interested in doing some sort of a routine work, even if you take up jobs, right? So if you want to do something exciting in your career, if you are in the final year, pick something here, right? If you are a PhD student, pick something here. Because by the time you finish your PhD, the topic would be usually on top. At that moment, you will get good jobs, you will have more opportunities, you will have more opportunities for doing research, right? So keep looking at this because it's also important for you to know what are the technologies that's going to be there now. Okay. Kevin Ashton was the first one to coin the term called Internet of Things. And he is from, anyone? Very interesting. Do you know where he worked? Colgate toothpaste. Okay. So he worked in Colgate. He was maintaining the goods and then managing it. So he was working with RFID and other things. And that's where he coined the term Internet of Things. He wanted to make sure that the raw materials that he gets and also managing the products, managing the warehouse was what he was looking into. And he tried to automate. So he wanted to make sure that the raw materials are all tracked. And then there are all the things that he wanted to connect. And that's where he coined the term Internet of Things. So it usually refers to uniquely identifiable objects. Okay? But according to me, it has to be also intelligent. So if you simply connect, you can connect many things, right? But according to me, that's not Internet of Things actually adds value to the things that you are putting it on the network. So what you can get is, if you can make it intelligent, if you can bring the devices such that they can do something better, right, together, and that's where the Internet of Things is valued. So what I will do is, I will basically talk a little bit about this intelligence part. Okay? So shall I go a little bit faster now? Sure? Okay. Maybe I'm also talking a bit slow so that you can sleep well. Okay. So there are some applications. So this is something with respect to warehouse you can easily get. So if you have multiple boxes, parcels, nowadays people already have the RFID tags, right? For example, your check-in luggage in the airport, how do they track? Previously they used to, if you take the tag, luggage tag, and then if you open, you'll actually see metal, which is the RFID tag. So, but these days there are intelligent ways of looking at the barcode, and then they look at the barcode easily, and so that they don't have to waste metal and many other things now. So basically the idea is to track the bags. So if you go to, let us say, Amsterdam airport, and if you're transferring from one plane to the other in Amsterdam, even if you have, let us say, about 45 minutes of switchover time, your luggage will not be used, and they're putting it onto the next flight within 45 minutes. That's because they track each and every luggage so precisely, and they have also built the network so that it is also properly bifurcated and then sent to each and every gate easily. And this is Rotterdam. You could see Maasliv's river, and it's a delta where Rotterdam used to be the top one harbor in the world, like 10 years before. But these days, Singapore has taken over, so the amount of cargo that comes into Rotterdam is much more. For most of the European cities, big cargo comes into Rotterdam, and then Netherlands being such a small country, and also Rotterdam is not that big, and also the harbor, but still they were doing business and making lots and lots of money by supporting the activity. So they're already using lots of connected devices to track the cargo, right? Huge metal boxes are there, right? So that's how they ship from one place to another place. And for example, estimated time of arrivals, estimated time of departure of each and every goods, and then the trucks that are carrying these cargo. So they all need to be managed, because you don't want to keep the ship at bay, right? Because that will cost more money, and managing also is going to be difficult. The other application is, for example, intelligent shopping. So this was one of the projects some time back supported by European Union, and this was with respect to making the shopping much more intelligent. For example, you should be able to find out the goods, for example, vegetables, which are going to go bad. For example, maybe in 1 week or maybe in 3 days, the vegetable is not going to be useful. So what you can do is sell it at a lower price, right? And then it's okay if you can buy some vegetable a little bit more this week, another vegetable a bit more next week. But making it or throwing it out as a waste is going to be not so good, right? So we have seen lots and lots of our farmers here in India. Sometimes they grow lots of these vegetables, but nobody uses it. So there can be a good balance between consumers and the producers. And if you can do that balance, that can happen only if you connect farmers and the shops and the consumers together, right? And this was one of those projects that was done. And of course, pharmaceutical industry. If you want to have job security, that means nobody will fire. In TU Delft, our university fired 7 professors. So there is nothing like permanent job. Okay, so we have to perform, and they also look into what is the research, whether the research topic is relevant or not, and that's how the life moves on there. So if you want to have job security, join pharmaceutical industry, because the concept or conceptualization of a drug and making the drug, testing it again, and testing it, and then going back to the animals test, then giving it to some humans who are guinea pigs, right? And getting the certification, it takes 14 years. So your job is guaranteed for 14 years. But the problem with pharmaceutical industry and the drug is that you have to have a repeatability, right? You cannot have the drug doing a miracle when you do first test, but ultimately in the second round it's getting failed, because you have to keep the physical parameters exact, the composition of the chemical exact, pressure, humidity, right, and the weights of the chemicals that you are going to mix, and the process need to be really tracked, right? So that's where you can use Internet of Things a lot. And of course, hospitals, when treating the emergency patients, keeping track of, because you have to go and then look at the patients if there is a emergency, right? So you cannot be always near to the patient. And if you are unable somehow to see the situation of the patient, you should be able to attend to them faster. So I don't know whether you have seen ICUs. You'll always hear about beeps. So those beeps are because your ears can keep track of that, and a particular type of beeps, frequency or the beating, can actually give you an indication that you have to go and then look at the patient faster. And you can be also doing something, right? So that's where you require Internet of Things to monitor the patient. Okay, so I will not talk about this, and I think I should be able to play. Carefully watch this, okay? One second. I'm going to ask questions. Some more. Probably I'm not going to show the video. I want to ask you one or two questions. What did you like in this short 3 minutes video? It can be anything, right? Don't shy away. Huh? Huh? Animations, okay. Okay. Very good. See, something that you have to identify, right, is that stereo is for enjoying the music, right? Now, what did she use it for? So, that is the power of Internet of Things, right? It looks very awkward when I say that's the power, right? But just imagine that something that you use for some other purpose, because it's connected to Internet, right? So, of course, here it's the human intelligence that came into picture, because she thought about, okay, this is the best way, right? So, because he cannot go and then, or at least he has to get up and then go and then switch off the stereo and then come back and then sleep again. And if the person is lazy, then he cannot do it. So, it's proof by contradiction. So, he has to get up anyway, right? So, the idea is that you can bring that little intelligence and then you can do this. So, the idea is you make applications, of course, and then put them together. When you mix and match, right, you can get multiple types of applications and services. And that's where when I said intelligence, connectivity, and applications come into picture. So, Internet of Things is ultimately all about making new applications and making things better and better, right? From energy point of view, comfort point of view, right? Resources point of view, it can actually do lots of things. And Ravi Prasad is from your state, right? Correct? Okay. I met him in Delhi once. There was a consultation, there was a committee. I got a call from Sushma Swaraj that time, and then went, sat there all day, giving the presentation. So I don't know whether he liked. He was the IT minister at that time, because government of India is doing smart cities, right? Now, think about the other way. Don't jump into smart cities. Try to make a sustainable. So you have Patna, whatever the state now, if you can maintain the same state, you are not improving, let us say for the next 5 years, then you have done everything smart. And that's what, whether they liked it or not, but at least they didn't tell me go. But what you need to think about is looking at the Mother Earth, right? And that's where you can actually bring much more value with respect to what you have been doing or what you are learning, right? So think about the sustainability. Internet of Things can actually help in building that, okay? So then you would have done everything smart. Last question with respect to video. How many sensors were there? That's why I asked you. Look at it carefully, because there were always links, right? Fridge, eggs, shower, occupancy. So there must be so many sensors, right? So how many of them were there in those 3 minutes? You can guess. You lose nothing. You may gain a chocolate, right? 7, 13, 18, 10. Okay, next. 9. Okay. 3. No, definitely not. There were so many. No. Okay. So around 25. The part of the video that I showed you. So there were about 25 sensors. Okay. Anyway, so we'll go ahead, and you're all from a premier institute. So you would like to know what are the challenges on which you should work on, right? So some of the things are heterogeneity. Now go back to the video. You could see that there were so many sensors, different types of sensors, right? So that's something that you would definitely need to address, because each sensor is capable of doing different things, as well as it requires different amount of energy, communication capability, the form size, it depends on various aspects. So you have to bring all of them together. And scalability, of course, I talked about it, right? If you are going to have 50 billion devices, you should be able to connect them together. That's a big challenge. And interoperability, you cannot say that only Google will manufacture these devices, right? So that's not going to happen. And each and every company is already bringing newer and newer sensors, devices, television sets. You have so many of them, right? The funny thing is that iPhone doesn't connect to a Samsung phone on Bluetooth, right? Have you observed? Isn't it? Fine. That's a different discussion altogether, but you would like to connect them together. If not, it's of no use, right? So then the last thing is about security and privacy. Probably, I don't know whether you would have noticed, about 2 years back, 2.5 years back, when you say google.com, the google.com page was not loaded. You could not access. You had internet connection, but you could not see google.com. I don't know whether you were, for almost 2 days or 2.5 days. So 1/4 of computers around the world, 1/3 of computers, they were not able to get connected. Because when you say google.com, what happens is it sends a query to a DNS server and then gets the IP address, and Google has multiple servers. So the one which gives you the fastest will be taken so that you go to the nearest server, right? And that's how they have. They have their central data centers in each and every country or big locations, and that's how they serve. So in Washington, there was in somebody's house, there was one, you remember?
So like someone bought google.com actually.
Yeah. So a small device that was hacked, and it's a simple Internet of Things device, some temperature or some other sensor. And through that, they brought the whole DNS service system around the world down. So they had to really struggle to get it up again. So now you can imagine what people can do or hackers can do if they gain access to all these devices. So security and privacy, by all means, if you are intelligent enough, I'm not that intelligent, that's why I'm not working. So if you are intelligent enough, you should be looking into security and privacy. That's going to grow a lot more. 15 days back, one of our master students, he got 10 out of 10 is for his thesis. So probably in this year, I think he's maybe 1 or 2 students out of these 25,000 students got 10 out of 10. And his thesis is inadvertently making the cyber criminals rich. So look at the thesis, it's available. So it's a good thing. I think I will not look into go into details. So some of the conceptual things where you try to define the knowledge, you try to define, take the information, put them together, how you can provide from the real world, go to the virtual world where you can process the input of the data and then come back and then use it back in the real world. So this is one of the projects that we were part of. What I would rather do is I talk about one small part of my work that was published later in IoT journal. So the idea is like object-oriented communication, object-oriented programming, right? So you have objects for each and everything, correct? So you can make small objects, then inherit that, right? And then you can actually compose multiple objects into another class and then make a bigger one, right? So you have done some programming, C++ or Java coding, right? So Internet of Things also you could actually put it in such a fashion. And that's where you could gain a lot of things. So what we said is, if you take any sensor, even a car is represented as a virtual object. And if the device is very small, if it is a temperature sensor, it will simply tell you one number through the communication means that you have, nothing else, right? So, but you can still do some little bit of, put some intelligence in that device. For example, if the temperature is same, you don't need to send, right? So you can save the battery for sending the packet. isn't it? And if you connect two or three of them together, you can actually bring some coordination. You can do a little bit more optimization. And if you bring multiple of them together, these COOs are called as composite virtual objects, and you can actually build much more services around that. This looks like just a big talk, right? But I'll show you what we did. So if you want to run, if you want to provide a service using Internet of Things, probably you will be following these steps. So you will have some events, that is sensing. You will have to do some mining. You have to look into what is that you have been sensing. 22 can be anything, right? So 22 can be number of people in this room, or 22 could be the temperature in this room, right? So you have to really get to the bottom and then say, okay, what is this number means? So you have to do some mining. Of course, you would like to log how things are varying, whether you need to take some action or not. So that step you have to do. And because you have cloud and other things, you can also upload. Maybe, may not be. But the next thing is to analyze and then take action. And then it goes back, right? So Internet of Things demystified is just this. So you have to go through these steps in some way or the other, okay? And how intelligently you do is the question. What I'll do is, I think I jumped down, but it's okay. When I was a very young boy, right, we didn't have tools in our house. If you go to anybody's in a small town, I don't think many of you will not have all the tools in your house, right? But if you need a hammer, you find something that works, correct? And only thing that you have to see is that you're not going to have this stone, big one, but you have to have a small one, right? That intelligence, if you bring in, you're already there. Many times I also do this. I use the kitchen knife as a screwdriver, right? You can use it. So now look back. It looks very unconnected to Internet of Things, right? But the concept that I want to say is that you can reuse the devices in different form, right? And that's what you could do. So now, if I want to enter this building, right? So I'm supposed to give a talk. So there will be somewhere listed that's my name, and I'm supposed to come here. But assuming that if I don't bring my ID card, so what can I do? Of course, if it is a nuclear reactor, I will not be allowed. You have to bring your passport and then authenticate yourself, right? But coming to a hall like this and then giving a talk is not that security risk. But still, you don't want somebody to come and then give a talk here, right? So if you don't have the, let us say, a fingerprint iris checker, so you can actually take a picture. But if you don't have a system, you can also use the video cameras and then just take one frame. You're done with, right? And you can also get the scheduled meetings, right? And you can also go back, look into my page, right? And then you can see the hits, and you can find out, okay, it has been there for a long time, so this must be the same person, right? And then I don't have the fingerprint thing, right? So I can do something. How many of you can remember the first page, the title slide? Very nice. 1, okay, 2. What is that? Yeah, hands, I agree. What is that? And this is what you could see. Could you see the grains? Right? So it is not a fingerprint scanning machine, but actually a normal machine. And that's where I kept my hands there. Okay. And with that, you can actually get the fingerprints easy. So you don't really need to have always the actual machine. So now put all of them together, right? You can have a threshold, you can have a match if it is enough for you. So you can allow the person to get into the building. So it is not that you should have always the exact things there. And that's where I'm coming into. If you really want to realize the power of Internet of Things, look for approximate services, right? So I gave you an example. I also gave you what can be done with ICT itself. And of course, this is one of my students. So he started using it, the coffee cup as a pen stand, right? So what I suggest is you cut the application into multiple functions, and then in case you don't have an exact function, you can always replace the function with an approximate function. And piece them together, you get your service. Probably that's an approximate service. But most of the times we are okay with that, right? So what I will do is I will move quickly to the other thing. And this is something most of you have done, right? This is also an approximate service. You don't have a leather ball, right? You still play cricket, isn't it? So you can definitely do something with that. Now, quickly I go into this part. We wrote a paper called Nonsense, and then the TPC chair sent an email saying that please change your the title of your paper. It doesn't look nice. Okay, so what you have done is you have multiple of these devices, right? So if I have only one temperature sensor in this room, and if it goes bad, then you cannot really control the temperature, climate control in this room, right? So normally what you do, you try to keep more of these. So I talked about virtual objects, right? So what you have is, you have many of these nodes, and you can create a virtual object there, correct? So the representation of the devices somewhere, maybe the server which is there, where you keep the representation of the sensors, actuators in the server. So those are the objects that is going to be there in the sink. Let us take a simple case of sink, right? So it is going to hold the value of the temperatures or the humidity that you get. And that's what the virtual sensor is. So what normally you try to do is, I played with, I don't know how many of you have done it. So it is very fun. Even now you can play. Okay, for playing, there is no age limit. Okay, you should always play and keep playing. That's important for your health also. So when we are young kids, I used to walk about 2 kilometers to my primary school. So sometimes we used to close our eyes and then hold someone else to walk. It's an amazing experience. Even now you can do that, because eyes capture too much of information, and most of the time your brain is, your CPU is basically parsing the data coming from your eyes. And once you close it, your brain is so free to can actually sense many other aspects, right? Physiological aspects. Try it out tonight. Okay? Close your eyes, walk up the staircase, right? You'll see a big difference. Anyway, so that means if you have two sensors doing the same thing, right? So I hold somebody else, he is walking, and then I just go with him. So I don't have to really sense. I don't have to see the road. So similarly, you can also do that. And these are the two nodes which are nearby, but assuming that you have the same thing in different places, you can still do that. So these two can be off, these two green ones. The blue ones can be on, and the greens simply follow the blue one, right? I don't want to get into all the things here, because you are intelligent enough to get into the things. So you can actually have an active virtual sensor. So that means you have a sensor, but it doesn't work, or it is not on. And there is another sensor, you use the another one to get what is the value from the other sensor, right? So that is the concept of virtual sensing. So you can actually have active, passive, so many types of virtual sensing. So in a nutshell, what you can see is that in the beginning you have these two sensors, X and Y, and they both are on. Probably you're not able to see. You could see that it is completely white, it is filled up a bit, right? You could see the shading, right? So if it is sort of shaded, then the device is on. here also it is on. So I observe, I have, let's say, about 5 sensors in this room, and the AC is somewhere nearer. So the temperature sensor near the AC will be showing a little bit less, right? And the temperature sensor which is a bit away from the AC will be showing a little bit higher temperature, naturally, correct? But they are correlated because both of them belong to the same room, correct? And that's the concept that I am using. So learn a bit from these two. You can use machine learning and many other things that if you want to make it much more useful or much more precise. And then what you can do is you can simply switch off the other sensor. And at 1 or 2 points, I simply sense from the one which is on. But even that sensor could be off. You could see the shading here, right? You could see the shading here. So in those places, the sensor X is on and Y is completely off. And once in a while, I switch on both and then try to find out if there is some sort of a divergence, right? Very simple. You can use any mathematical tool you want, prediction tools you want, right? And that's what we did. And I want to show you the results. So these are the 2 sensors from Alps mountains. So they take these sensors and then keep it on top of these mountains because they want to measure the ice, the amount of ice on those mountains, because they want to avoid people getting stuck when there is an avalanche. So they know, they have studied very well what is the temperature, because with temperature also the ice glaciers melts down and then comes back. So they would like to measure. But you cannot easily go and then plant these sensors there. It is very difficult. They really require a mountaineer to go on top and then place it. So it is so difficult. The terrain is difficult. You cannot go like Mount Everest, right? Himalayas. So we took 2 sensors from there, and you could see that if I can guess one from the other, the error is only 0.3, right? 0.3 degrees centigrade is the error. So if this is more than sufficient for you, you can actually switch off one sensor and work with only one of them. So if there are 5 or 4 sensors here, only one is actually working at any point of time, or even that may not be working all the time, because you can also do a bit of prediction, right? So that's what you saw. Of course, you can change the amount of the number of ticks where the sensor is off, and when they have to recalibrate. You can always play around, and then if you recalibrate faster, the errors are less, of course, right? So you can also see the energy consumption. So without how much you are going to spend, so it's almost like more than about 40% you can save energy, right? And of course you can think about the error threshold and other things, right? So if you are able to tolerate 1 degree error in a room like this, 1 degree is not going to make a big difference, right? So you can do that. Now, can we use this for other domains, right? I said temperatures, correct? And one is a horse, the other one is a zebra, right? Now, look at this carefully and then tell me what it is. Do you see anything strange? Somebody answered a question that time. From where? Who? This side. Okay.
Do you see anything?
Any strange thing here?
We're using a light sensor to predict temperature.
Very good. So I talked about temperature sensors, right? Right. So here is a light sensor telling the temperature. Can you imagine? Of course, the error is a little bit high. It's 2 degrees instead of 1 degree, but it can still work. You could see now what you can do, right, with this. Anyway, we did many other things. what I will do is, this is one of the nice problem for computer science students. So if you have virtual sensors, if you switch it off, then how do you make the connection? And still be able to get the data from all the sensors as if that you are getting, right? It's an NP-hard problem. So you can keep solving for next 2-3 years. What I will do is, I will show you the power of virtual sensing with a small video, and then maybe I will take some questions. So this is something called ASHARE, which is American Society for Heating, Refrigerator, Air Conditioning Engineers. So what they have found is, when you say you are comfortable, it doesn't mean exact temperature of 22.53 degrees centigrade, right? So human body, depending on whether it is male, female, tall, short, big build, thin, right? Depending on your body type, so the concept of comfortness varies. So, and also it depends also on the humidity, right? Dryness, humidity, and many other aspects. Light, amount of light that you have. So it is not one small thing. And that too, if you are, how many people stay in one room here in the hostels? One per room or 2 per room? In a, huh? Okay, first year students will be like 2 people in a room. Okay, 3 people in a room. Okay. So you will always have a problem, right? One wants fan, the other one doesn't want, right? It is an eternal problem. You cannot solve it easily, right? Okay, we try to do that. So the idea is that what is comfortable for one person, right, is what you should actually look into. But something that we found, what we did is we made a simple app. I think I will just go ahead with that. So you can actually find out what a person feels, right? Whether it is really hot or cold or anything in between. Similarly, lighting also. Okay, so we found out that there is something that a person is comfortable from here till here. So from 20.25 degrees, this particular person is okay with 24 degrees. So that means there is a band in which he is comfortable. Now you know what to do, right? So if another person is there, and if his comfort level is something for the red here and for the blue here, what you need to do is you need to select anything here. So now whether you want to select this or this, which one you select? Want to select this point because this is in the comfort band of red as well as blue, right? So you can select this point. So you want to select this point or this point. Which one you want to set? No. Why do you want to select middle? No, here also he is comfortable, right? So this is the preferable range above this. So this point blue is also comfortable, and of course red is also comfortable there, right? So you can select this. It depends on where you are. If you are in Patna, you select this. If you are in Delft, you select this in the Netherlands. I'll tell you why it is. Because in Delft we heat the room, so you can heat less. In Patna you actually cool the room, so you don't have to cool down to 18 degrees. You can only cool down to 22 degrees. So depending on where you are, you can actually also save resources, right? So this is what you could also do with virtual sensing. What I will do is I will simply, I will not go to this level. Of course, you have to solve lots of these algorithms if you have multiple light bulbs, which I will show you through a simple video. Okay, and this if you have so many of these light bulbs, and if there are more than one person in this room, so you have to manage the intensity of the light bulbs such that each and every one in that place should be comfortable having enough lighting. But the global aspect of total amount of energy that you are going to burn should also be minimized, right? What happens is, it's a human tendency that we have also observed. Okay, maybe this question I should ask. I showed the video, right? So, where did I end it? Remember? Office? And then? Window was open. Okay, good. Somebody else also said the same thing here. This side. Okay, I'll come back to you. Both. You already have a chocolate, right? Okay, good. So, what you can do is, in the Netherlands, what happens is, a reminder. So, what normally happens is that there is a lot of cloud cover, it rains, and after half an hour, everything will be clear, and you will find lots of sunlight. So, normally when there is huge cloud cover, we go and switch on the light bulb, but afterwards, we don't get up and then switch it off. So, the whole day, the light bulbs will be on, and that's what actually makes us spend unnecessarily energy. So that's what we try to avoid with this application, while you give comfort level, but you also make sure that you use less amount of energy. Okay, so I will simply stop all those saying that okay, we saved so much of energy and things like that, but you should be able to get some sort of an idea with this video. It's just a 1.5 minutes video. So these were my PhD students, and this is how one of the students' room in our building looks like. A huge window to get the energy, the light, and we have used Philips Hue bulbs so that you can control. This guy is with Microsoft Research now in Bangalore, and he is with TCS Research. Both of them came back to India. You could see that slowly changing, because you have to find out the proper operating intensities, luminosities, right? So we use 6 of them. So you have to adjust the amount of light intensity from each of these bulbs, and also knowing the distance between the bulb and the person where he is sitting. Okay, so here we use the concept of virtual sensing also, because you need some sensors, right? Now, let me ask you 1 or 2 questions and then I'll stop here. How many light sensors we used in the room? Can you guess? Okay, let us ask a simple question. How many light sensors we used? Because you require light sensing, right? I want to know what is the light coming from the window, right? Isn't it? Okay, so totally how many light sensors we used in this? 2, okay. Any other guesses? 8? 6? 1? Okay. Yeah, I wish I could do that. Okay. How many light sensors overall, totally I used in this experiment? Did I ask the same question earlier? Okay. How many light sensors inside the room then? Is it the same number or different? So, somebody said 1. Who said that? Okay. We used only 1 sensor, light sensor, not inside the room, on top of our building. Okay? Because we use simply we use the concept of virtual sensing. The window size is fixed, it doesn't change, right? And then we want to get as much energy as possible, so we don't put the blinds. And that's where I said I connected with the video that I showed. Because as we entered the blinds went up, right? So that you can get more energy light from outside rather than switching on the artificial light, right? So what we did is, if I know what is the luminosity outside at any point of time, any day, I know how much is the luminosity in those tables, right, or near the tables. So I require only one of them. I don't have to have multiple of them, right? And then we knew exactly how much lighting each of these two guys wanted because of the simple survey that we did. So what we did was we developed this app, and then we asked this question randomly. So one day at 2 o'clock, at 2:30, 5 o'clock, right? The next day 10. So like that we collected the data over a period of 7 days, so that at different intensity levels we found out what is the luminosity they have outside, and then how much they were getting inside. And once I know that, what is the band in which they are comfortable. So similarly you can also do it for heating. So this one is easy to show. Heat I cannot show, right? So lighting you can see that what is they are comfortable with. So then we simply said they simply carry their mobile phone. That's what they do always. So with the mobile phone I know whether they are inside the room or not. That's more than sufficient. And if I know what is the lighting outside, I can exactly set the lighting that they require. The beauty of this is, tomorrow if the person goes and then sits in some other room, I can still set the same light intensity there for him, right? So he'll be carrying his setting. He need not do anything, right? He need not switch on, switch off, and reset, nothing. So what he needs to do is he needs to simply carry his mobile phone to make sure that he is at that place, right? So we used virtual sensing. Of course, we used Internet of Things, localization. You could see that we've got multiple smaller aspects, right, put together, then you can do something amazing. What I didn't, or I skipped, is you could almost save, in some cases, almost like 56% of energy. We published in EWSN, European Wireless Sensor Network Conference. Maybe you can have a look at that. And at least, at a minimum, at least 33% of energy we can save. It's a big thing, right? So saving 1/3 of unnecessary spending is always important, at least for Mother Earth, right? So what I suggest is, look beyond what you see. Think of connecting multiple things, right? Different domains, put them together, you can make amazing things. And that's not easy. Of course, you will have to learn, you have to use multiple tools that you are going to learn in a top university like this, but you can definitely achieve much more than this. And I stop here. Thank you so much for listening. In my class, I also do one thing at the end of each and every class. I post it on one of the online platforms. That's called the sleep counter. So how many students slept in my class? Okay. So today I saw, I can put, let's say, half, because he was half asleep. So, but I'm happy that only one slept in this presentation. Good. Thanks a lot.
So any questions?
Yeah. Quick. I need to run for something else.
Things would like make people more dependable on things. Like taking this example, let's say because of some reason, the server where the lighting is handled, like it shuts down to something, and then the person has to manually do that stuff, right? So with the lighting and everything, because now this is all totally automated. Don't you think Internet of Things is people more dependable on technology, and that's also not good enough?
Okay. Now, what are the options is what you have to look at, right? One is making people not dependent on technology. It's very good. Going to the roots, doing things on ourselves, then that's much more healthy, right? But are we doing it? Correct. So what is the alternative? If people get up and then switch it off and on when they want it, then I don't need to do this, solve this problem, right? But because we observe that people are lazy, you need to do something else. Making them work more, you can always use some other tools, right? So not only these two, but you can always use the technology to make sure that that's where I also gave the example of sustainability rather than smartness, right? So these things will help sustainability. To help sustainability, you necessarily need to be smart. So look at the target as sustainability, then you will be smart anyway. Yeah.
Thank you very much, sir. This is a very memorable and proud moment for us. So now I would like to request Dr. Siparna Sir to present a memento.
Thank you so much for, it's an odd hour, right? 3 to 4:30. I'm happy that you turned out. I hope you enjoyed, and also I hope you are going to do some more great things in this university. Okay. Yeah. Yeah. So there are so many of them, right? There are so many. Look at 802.15.4. Okay. If you look at 15.4, you have A, B, C, D up to W now. So most of them are for sensor. If you look at the LoRa now, long range communication. Look at NB-IoT. These are all the technologies that is being used for bringing the sensors or actuators to the internet. TCS in Netherlands actually using much more sensors than here in India, right? So Tata Steel, they have a company. They actually bought. I forgot the. So now they are running the factory, but they have put lots of sensors, and they are all connected over LoRa. So you have already enough number of communication technologies substrate for carrying these information back. There are a lot more things. Okay, and apart from that, you also have 5G now coming into picture. So with respect to 5G, you also need to have a SIM card. With NB-IoT, you need to have a SIM card. But if you really want to make it so cheap and completely inexpensive devices, LoRa is always there. So you put these LoRa devices and then you keep sensing, but not for really the lighting that I was talking about, because LoRa is having very less duty cycle. Probably you cannot use it there. NB-IoT or 15.4 series, one of them. But there are already for you to connect. The problem is, how do you interface across this? So interoperability is going to be a big issue. So that's what you should look.
Thank you. So I would like to thank Dr. Pritam Kumar and Dr. Siparna Sir for their vision. Without their support, this would not be possible. I would also like to thank Pratik and Deepanati for their support. Thank you, everyone. Some refreshment outside this hall. Thank you very much.
Yes.
Really good.
Not having that much energy today.
No, yeah, so